Hi, Michael. Hope all is well with you. I'm just going to make you a little video for a couple of things. You've confused me a little bit. You've said like lesson 2, solving by graphing, but a similar video, lesson 1, solving by graphing. So I assume you mean by factoring for lesson 2, but I could be kind of messing up. Um, if you look at the previous video that I made for you, it was basically lesson 2 and lesson 3, so it was solving algebraically. So one is by factoring and one is by the quadratic formula. But what I'm actually going to start out with is looking at your assignment because that might tie in a little bit of it. And I was also looking for the online calculator and I can't find it now, but I'm just going to use this as a bit of a online calculator. If you're having problems with your Casio, I believe you're using, if not, if it's a TI, awesome. Use that green sheet for any of the functions that you need. This one, I don't actually know what I'm doing. I just found it quickly, so hopefully it will help us out. So looking at your assignment, so the very first one, so it says solve the following quadratics by graphing and determining the x-intercepts or the zeros. So you've drawn it on here. Your sketch is a little funky if I'm not mistaken. I think it should be. So it should have a maximum of around 7 right here. Oh, it won't let me right now. Oh, wait, I've got my tablet plugged in. Let's see if it'll let me. No, it will not. Um, so it'll have a maximum at 7, but it crosses at a couple different points. I've got another good idea of how I can show you how my graph looked, but sometimes my graphs look a little funky on this one, I know. Um, Sorry, I should have had this one open too. Oh, I thought I had the key for it scanned. I have it sitting in front of me, but I do not have it here right now. But the big thing is it says solve by graphing, right? That's kind of the important part with this. So it looks like you were doing the quadratic formula, which cool. If you're awesome at it, that's great. It can get you there. But the one thing I see right away is you have 3 minus the square root of 51 divided by 3. But remember that in the quadratic formula, oh, I've got another good idea. In the quadratic formula, there's that plus and minus in between. So, sorry, I don't want to restart because I don't want to redo everything I've already done. So I'm just going to do this. So from the assignment, let's do some screen captures. Does it make the loud noise on yours? Hopefully not. So we'll just put these ones in. I always get freaked out and then I need to look that it's actually recording. Okay, we're good. So if I go to Smart Notebook, because now I can actually draw on it. So solving it by graphing. Honestly, graphing, if it doesn't tell you, graphing should be your priority over the algebraic methods anyway. So you want to make sure that you know how to actually do this. So just to go back again on your sheet, it looks like you did the quadratic formula. So you had 3 minus the square root of 51 divided by 3. So using the quadratic formula, this is so irritating. So 3 minus the square root of 51 over 3. But looking at the quadratic formula, remember that it is x is equal to negative b plus and minus. So that plus and minus square root of b squared minus 4ac. Boop. Divided by 2a. I was wondering how you got to 3, but a is negative 1.5. This might have been negative 3 on the bottom, no? I'm not going to go back to your thing, but you can solve it algebraically. That's totally fine. But what I want to do, and I want you to practice with your graphing calculator as well, is try putting that into your graphing calculator. So in your y1 of graphically, putting in negative 1.5 x. I assume I can do this, x to the power of 2 plus 3x plus 7, and then graphing it out. So this is what I meant that your drawing on the graph looked a little bit different than mine, because you see how you have your intercept like over here a little bit on the other side of -3? It should look more like this guy, that it has a maximum. Oh, sorry, no, I guess the 7 would be your y-intercept. Then it has a maximum somewhere around 8.5. And it has two x-intercepts. So it has one right here, which we really can't see. If I look at my table, nope. Sorry, again, I've never used this calculator before. Whoa. Got it. So equations, if I want to add another equation, just because it doesn't tell me the line y is equal to 0, just because it doesn't tell me that I can do my roots, I can look at my intersection. So it's done my second line as the line of your x-axis here. And I'm going to just look for your points of intersection. So plotting our 2 points of intersection would be the same. I forget in Casio if it says you're calculating or you're tracing your roots or you're calculating or tracing your zeros. I think it says roots. So make sure once you've put in the first equation, again, if you're a little bit behind me, pause the video and put in your first equation. So y equals -1.5 x squared plus 3x plus 7. You don't need to put in the second one. I'm just using a silly online calculator. And so when you go to figure out your points of intersection with the x-axis, or what we'll call your x-intercepts, or what we can also call your zeros or your roots or your solution, since it's equal to 0, we have two different points on there. So we have -1.38, which you actually got, right? You got that first point, which you really didn't represent in the graph here very well. So you got that first point through your quadratic formula, but you didn't do it graphically. So you missed that there's a second point, even though you drew something on here. So your 2 points of intersection should be -1.3804, and the other one is at, sorry if I go back there, 3.38 is your other point of intersection with the x-axis. So hopefully that kind of makes sense. In your lesson booklet, if I'm flipping back to it, do I have it in front of me? Maybe not. Oh yeah, I do. So in your lessons booklet, there were two different methods in there. And so I had kind of said, use that method 1 where you set everything equal to 0. So if we look at our other examples, so again, the answers for this were, let's full screen this. So the graph looked something like this. And again, your graph doesn't have to be absolutely perfect, but it should be relatively accurate that your one point of intersection is between -1 and -2, and your other point of intersection is between 3 and 4. So you shouldn't have your intersections represented out here the way you did. You should have your close to where the maximum is. You should have your y-intercept correct. Those are a couple points that you can kind of throw on. It doesn't have to be out of this world amazing. You can see mine's not perfect, but it's representing our equation a little bit better than yours was. So again, our values for x that made that true, x equals -1.38 and x is equal to 3.38. And so one thing that you typically want to do is verify both. You can sub them into the original equation. So substitute into the original equation and make sure that your left-hand side of the equation is equal to the right-hand side of the equation. So they should both, in this case, be equal to 0. So 0 is equal to 0. And again, you need to check with both of these. So do them independently and make sure that they both, when you substitute them in, they get it pretty close to equal to 0, right? If, again, you see that our values from from here, they're rounded values. So negative 1.3805 and positive 3.3805. If I'm just putting in negative 1.38, I'm probably going to be off by a little bit when I do the verification process. Here, can you stop talking about it and just actually do it? So let's do this. I'm just going to do the second one. So 3.38 is equal to x. So our original equation was negative 1.5 x squared, 3.38 squared plus 3 times 3.38 plus 7 equals 0. Oh, I've run off the edge of the page. So extend page. So I'm just going to use the calculator on my phone. 3.38 times 3.38 times negative 1.5. So this part translates to, so remember order of operations. You do exponents before you do multiplication. So I'm going to do 3.38 squared and then multiply it by negative 1.5. Negative 17.1366 plus 3 times 3.38 is 10.14 plus 7. So now adding those up, so what I end up with is negative 0.0034 is equal to 0. This is pretty darn close, right? This was because we had that rounded value of 3.38. So essentially what we have is 0 is equal to 0. If I, instead of 3.38, I put 3.3805 or whatever it was, this would get even closer to 0. So know that if it's not totally right, it's probably just a rounded value. If I got something like 7.0034 equal to 0, no, that's not true. 7 is not equal to 0, but almost 0 is pretty much equal to 0. It's just from those rounded values. Okay, so on to the second one. So maybe quickly just pause the video and try this one graphically, Michael. I don't know if you did. I'll check back in a second if you did it graphically on your sheet, but try punching it into your y equals button on your calculator. Oh, one thing with this is, ooh, I don't know what I'm doing there, to the power of 2. So the thing with this one is right now, we have it equal to 8. And so as I was mentioning before, we want to do that method 1 where we end up bringing everything to one side to set it equal to 0. So what I need to do to move this 8 to the other side, I know I need to subtract 8 from both sides of the equation. So 2x squared plus 7x plus 7 minus 8 is negative 1. And now we have that equal to 0. So this is what you want to put into your y1 is this. So now I'm going to go finish doing that on mine. So 2x to the power of 2 plus 7x minus 1. And so when I graph that out, it looks like this guy. So let me peek at your sheet. Okay, so what you might have done here, okay, I'll have to peek at this again in a second. You're close, except not a negative, but again, you're doing this by the quadratic formula right now, and it should work, but once again, you're not doing the plus minus situation that you should be, and I'll have to peek at this again. So going back, hopefully you've graphed it into your calculator and you get a graph that looks something like, so I know that my y-intercept is going to be at negative 1, right? Because your c value is always your y-intercept. And then just getting a bit of an idea, it looks like my maximum is somewhere around x equals -2, a little bit less than that, and y is, let me just go to the actual graph. So yeah, so my maximum is just below -7, and it's just ahead of the line of -2, so it's between -1 and -2. So when I would draw that out, again, between -1 and -2, so just somewhere there. And then it looks like my intersection points with the x-axis are kind of somewhere here and somewhere here. No, not quite that far actually, it's right here. Sorry, I can't cross that one out. And so you would just, with a relatively smooth line, plot that out. I'm going to do something again later to show you if you hadn't done this step for rearranging, what it would actually represent. So looking at our graph again, in your Casio, you're going to trace, I think it says zeros on Casio. On the TIs, it says roots, but I'm pretty sure it says zeros. And you can you can do almost what I'm doing. If I do this one, is you can scroll back and forth between it. So you can click on one, and then I think you just press the over arrow on the Casio, and it bops you over to the other one. But this has given me my 2 points of intersection. So our points of intersection are -3.675 and positive 0.1375. So 2 points on there. And so again, that would have come from that graph that we plotted onto here as well. But we used the calculator to figure it out. So full screen. The other thing that you could have done, and I'm not sure, I'll look at your graph and see if you actually did this. Eraser. So if you hadn't done this step, I'm going to show you if we hadn't done that method 1 and instead had gone to the method 2, what that actually represents is putting in our calculator 2x squared plus 7x plus 7, and then I'm going to put in my other one, y equals 8. So the other side of the equation, you see how it was equal to 8. So what that would represent, hopefully you're watching my screen right now, it's going to change the graph actually. So what you'll see is, I guess I need to actually plot this. What have I done? Oops, don't want to do that. Remove equation 3, sure. So you see that the graph goes up. So it looks a little bit different than we had it before. And this kind of purple line, I can't tell if it's purple, runs along the line y equals 8. And so now when we would trace the intersection of those two lines, we see that they intersect at that same number for x, so -3.675 and 8 now. Last time this number was a 0, and positive 0.1375 and 8. So you see that our points of intersection are the same for our x values. And again, it's because it's asking what values for x actually make this equation true. So just to kind of recap, from our lesson solving quadratic equations graphically, we could have done, method 1, and so that's set equal to 0, so subtracting 8 from both sides. So subtract 8, 2x squared plus 7x minus 1 equals 0. And then in your y1, you put in 2x squared plus 7x minus 1, and you're going to trace zeros. Hopefully that kind of makes sense and you remember the graph that I drew for that. So the method 2 is you're going to put in y1, the left-hand side of the equation, and y2, the right-hand side. I don't know why I didn't put the h in there. So graphically, in y1, you're going to put 2x squared plus 7x plus 7, and in y2, you're going to put in 8. And in this case, you're going to trace the points of intersection. And they will both be the same. Oh, sorry. Same values for x. So again, those ones that came up, so x equals negative 3.637 and x is equal to 0.137. So as well, just to go over it, since you seem to be doing the quadratic formula for that one, I just want to do it just to see where maybe your mistake came, because it looks like you have a little bit of a mistake. You had this as the positive value, so positive 3.367, positive 3.637. So you made a little bit of a mistake there. So again, x equals negative b plus and minus square root of b squared minus 4ac divided by 2a. And so negative b, what we need for this one is we need our standard form where we had it set equal to 0. So we need this one. You can't use your original equation because you need it equal to 0. Sorry, I was doing that with my keypad or my trackpad instead. So negative b would be 7. Oh, 4 times a times c. So a is 2 and c is negative 1 divided by 2 times a, which was 2 again. I just want to compare this to the answer that you had, Michael. So for this guy, so negative 7 plus or minus square root of, so 7 squared is 49. Negative 4 times 2 times negative 1 is going to be plus 8 divided by 2 times 2. So 49 plus 8 is 57 divided by 2. So just peeking back at yours, your, oh, did I say 2 at the end there? I think it should be 4 like you said. Yes, sorry. I ended up with, let's get my eraser. Whoop. Oh, too much erasing. Yeah, I messed up that bottom part, so it'll be goofed up from yours. So the big thing that you were missing was this plus minus. You might have also not had a negative in front there, so that might have been the problem as well. So that should get us, if we do negative 7 plus the square root of 57 divided by 4, and so both cases, negative 7 minus square root of 57 divided by 4. So just quickly punching that in my calculator on my phone. Negative 7. Uh-oh. Now my phone won't go into the other mode. Okay, you do it on your calculator and hopefully you get to those two answers of x equals, so the positive one, 0.137 and negative 3.637. So that's your second question there. The last one, again, two different ways you can solve it. This question C, it's just a bajillion times easier if you put it all on one side, because trying to figure out where two quadratics interact is actually quite the process. So this one, from those methods that we had on the last page, I'd say you definitely want to be doing that method one. So that's, again, set everything equal to 0. So bring everything on the same side of the equation. It doesn't matter which way you move it, if you move it this way or if you move it that way. I'm going to take the lazy way and only move two things. So I'm going to add plus 3x squared, and I'm going to subtract 6x from both sides. So plus 3x squared and subtract 6x. So now I'll have 0 as negative 3x squared plus 3x, and positive 6x subtract 6x. And so on this side, I'm going to have negative 2x squared, and I'm going to be adding 3x squared. And then I'm going to have positive x, and I'm going to be subtracting 6x and positive 2. I did method 2 on my calculator, and it was a bad idea, so hopefully I get to the same thing. So negative 2x plus 3x is positive x squared. Positive x subtract 6x gets us 5x, negative 5x, sorry, plus 2. And that again is all equal to 0. So in this case, in y1, put in x squared minus 5x plus 2. And if we do that in the weird graphing calculator I have, let's remove this. Uh-oh. Y equals, so x squared minus 5x plus 2 minus 5x plus 2. And I'm going to add on another one just so I'm interacting with my x-axis. So it looks like this. And so again, I need to trace the intersection just because I don't know if my dot is hitting exactly on that point of intersection. It's pretty close. But as you can see, if you look up at the top where that red dot thing is, it doesn't say exactly 0. So I'm going to trace my intersection on your calculator. Again, you're going to be tracing your roots or your zeros. So it plots our points of intersection. So it plots this one as 0.4384, and it plots this one as 4.5616, of course. So that's doing that question by that method 1. I'm going to show you the other way as well. So where we put our left-hand side and our right-hand side. Hopefully you have down what you need here. I'm going to show you the way that we can put it in the other way, where we can, wow. I'm going to put this into y1 and this into y2. And then I'm going to trace the 2 points of intersection. So on this side, it's going to be y1 equals negative 3x to the power of 2 plus 6x. So that's my left-hand side. And on the other side, negative 2x to the power of 2. Hopefully I'm typing these right. Plus x plus 2. And so when I would plot these, what you see is I get two quadratics. And I can see a couple points. Well, actually, I can only see the one point of intersection. So I can see the point of intersection here, but there actually is another point of intersection that's way off the page down here. So I think I didn't try this one. If I zoom out and kind of scroll down, I guess I can zoom back in. You can see that they're crossing over somewhere here. It's really hard to tell where, right? This one's pretty easy to see, but at some point here, they're crossing over as well. So I'm just going to actually zoom out a little bit further just so we ensure. Because if you look at the red line, so the red line's on the outside here, and then if you look way down here, the red line's on the inside. So somewhere here they have crossed. So it says plot the points of intersection, right? So we will do this. And it gives us our two numbers. So this is that first number, 0.4386, and this was our second number, 4.5614. So those are our 2 points of intersection. So this is that method 2 from the lesson that we have. So right now, Michael, I'm going to pause it just so this video isn't like 6 years long. And then I'm going to upload, I'm just going to look at a couple of your other questions as well. So here you go.